Welcome to 3.6, where we're going to focus on solving application problems involving equations. So let's dive right in. So here is the blueprint for problem solving. So let's go through these steps together so that we're all on the same page. This is a helpful process. The key, step one, of course, is to read the problem and then mentally list the items that are known and the items that are unknown. And in fact, you don't actually necessarily need to mentally list them. You can actually list them. And I would encourage you to read the problem the first time just to get oriented to the problem, and then to read it a second time for information, such as the known and unknown elements. Step two, then, is to assign a variable to one of the unknown items. In most cases, this will amount to letting x equal the item that is asked for in the problem. Then, translate the other information in the problem to expressions involving the variable. Draw a picture if it's helpful. Step three, reread the problem and then write an equation using the items and the variable listed in steps 1 and 2 that describes the situation. Step 4, solve the equation found in step 3. Step 5, write your answer using a complete sentence. This is important when you're solving an application problem because it's a real-world problem, so we need a real-world answer. Step 6, reread the problem and check your solution with the original words in the problem. Verify that your answer makes sense in the context of the problem. So basically, the strategy here is to read, to assign a variable to what is being asked for, the unknown, then to write an equation, and that's the part we'll probably focus on the most when we're practicing together, and then solve the equation. Now that's stuff that we've done in previous sections. Section 3.2, 3.3, 3.4, we were solving equations. So we're just going to be doing that same work, but from an equation that we've made up ourselves from a real-world problem. And then step 5, of course, we're going to write our answer in a complete sentence. And this is a very helpful part of solving application problems. And then the final step is to make sure that your answer makes sense in the context of the problem, right? If your answer is way outside of some range we might expect, that could be a flag, for us that it's not right. All right, so let's look at a couple examples. Example 1, the sum of a number and 2 is 8. Find the number. So we want to add, I'm jumping to conclusions here. It says the sum, and so right away I'm thinking about addition. So it says we want to add some things, and we want to find a number. So we know that x is some number that's going to be added. So let's see. The way I would do this is, now that I've read it, I would write it. I would say, okay, I'm going to let x be the unknown number, right? So I'll let x be the unknown number. And the sentence is literally the sum of a number. And whenever they say the sum of a number, right, number, that's code for an unknown. What number? Well, that's what we're going to have to find out. And 2 is 8. Now, notice I put a period at the end of this because this is a full and complete sentence. This is a true statement, or this is a statement. And we are going to translate it into a mathematical statement, and then we're going to solve it. So let's do that. Let's go ahead and translate. So we know that sum means addition. We know that of a number, and, so the and tells us where the plus is actually going to go. So the plus actually goes here between one number and another. So 2 is 2, right? That's not going to change. The number, that's what we're going to use for x. And the and, remember, tells us where the plus for the sum actually goes. Is code for equals, and 8 is 8. So hopefully you can see what's emerging here is, the sum of a number and 2 is 8. So that's how we translate from a word problem to a mathematical equation that we can then solve. And so we'll go back to our skills from the previous sections here, and we'll say, okay, if I want to isolate my variable, 2 is being added to it. Well, I've got to do the opposite of that. The opposite of adding 2 is subtracting 2, and I have to do it to both sides. 2 minus 2 is 0, so I just have x equals 8 minus 2 is 6. So the sum of a number and 2 is 8. Oh, the sum of 6 and 2 is 8. Okay, that makes a lot of sense in the context of the problem. So if I'm going to answer this, it says find the number. The number is 6. Great. Let's have a look at another one. So we may get some triangle problems. Something to know is that the interior angles of a triangle, they add up to 180 degrees. This is kind of an interesting phenomenon that anytime you have a triangle, the interior angles of that triangle will sum to 180 degrees. And so that's a piece of information that we know and that we need to know. Now let's go ahead and read this problem and start thinking about translating it. So it says the angles in a triangle are such that one angle is twice the smallest angle, while the third angle is 3 times as large as the smallest angle. Find the measure of all 3 angles. So we want to find all the measures of all the angles. We know that one angle is twice the smallest angle, and another angle is 3 times the smallest angle. So if I'm thinking about drawing a triangle here, and that may help me, if one of my angles is x, they're saying the other one is twice that much, and the third angle is 3 times that much. Does this make sense here? So one angle is my small angle. It's my unknown, right? I'll let x equal that small angle, and a little angle there. So x is my small angle. So then one of the angles is twice that much. It's twice as big. So whatever my small angle is, my other one will be twice that much. And then the third angle is 3 times as large as the smallest angle. So now we want to find the measure of all 3 angles. Well, how do you find the measure of all 3 angles? Well, the sum of all 3 angles is 180 degrees, right? So the sum of all 3 angles is 180 degrees. So now let's translate this. We know that sum is addition. So that means we're going to add all 3 of the angles. And we know what the angles are. I have expressions for all 3 angles. I know that is equals, and I know that 180 is 180. So the sum, so if I take all my angles, one angle is x, another angle is 2x, and another angle is 3x. In theory, if I add up all these angles, I should get is 180 degrees. Now, what I can do is I can go ahead and simplify, right? I've created an equation from the application problem, the words. Now that I've created this, I'll go ahead and solve it mathematically, and then I'll see if my answer makes sense in the context of the problem. So, okay, x plus 2x. Oh, that's x. So if I have 1x and I add 2 more x's, that's a total of 3 x's. Plus 3x equals 180. So I'm not done combining like terms. I've got 3x plus 3x, that's 6x equals 180. Now I've combined all my like terms. I've simplified. Now I would use the addition or subtraction property if I had any addition or subtraction to do, but I don't. So I'll move on to the multiplication and division property of equality, which says if you're multiplying x by 6, then to get x alone, you could divide both sides by 6. And as long as you divide both sides by 6, then it'll keep the equation true. So 6 divided by 6 is 1x equals 180 divided by 6. One way I can think about this is to kind of cover up the 0 in my mind and just look at the 18 part. 6 goes into 18 3 times, and then the extra 0 means it'll go into 180 30 times. Now, am I done? In a previous chapter, I might be done, but this is an application problem. So they want to know, what are the measures of the 3 angles? Well, all I did was solve for x. Well, I have to go back to my original problem to find out what that means. So in the context of my original problem, x is 30. Oh, so that means the small angle is 30 degrees. And then another angle, kind of the medium angle in this case, is 2 times x, so 2 times 30, so it's 60 degrees. And then there's a big angle. And that's 3 times x, or 3 times 30, or 90 degrees. Now the question is, do all these angles add up to 180 degrees? Does it make sense in the context of the problem? So let's see. 30 and 60 is 90. 90 and 90 is 180. So indeed, these would sum to 180. So this seems to be a reasonable solution to the problem. And here it is. This is the actual answer, where I've labeled the small, medium, and big angles with their degrees. And this is probably the best way to answer the question. And here is the rest of the kind of book explanation, and you're welcome to pause it here and see how that corresponds to what we just did. I think it'll make a lot of sense to you. So let's review what we did when we were solving these application problems. So the first step in solving a word problem is to read the problem. And my advice is to read it twice. The first time, just to read it to get oriented. Make sure you know all the vocab. Make sure you sort of understand the basic premise, what we're talking about. And then read it again to see what we're actually being asked to find, the unknown. Then, and I'm getting ahead of myself. So let's just answer that part. So part A, what is the first step? Read. That's the first step. Why is the last step of the blueprint for problem solving so important? The last step is to check your answer and see, does it make sense in the context of the problem? Well, an application problem is a real world problem. So your real world problem should have an answer that makes real world sense. And that's why it's so important. So you want to check to see that your answer is reasonable, right? Check that your answer or solution to the problem is reasonable, right? Does it make sense? Is it reasonable? All right, C. Write a mathematical expression equivalent to the phrase twice the sum of a number and 10. So twice the sum, twice means 2 times. The sum means add a number means x. The and tells you where to put this add, and 10. So this is a phrase, right? So it's not necessarily going to have an equals. I don't see an is here. It just says twice the sum of a number and 10. So it says twice the sum, so 2 times the sum. So this is when we have to use parentheses. The sum of a number and 10. Twice the sum of a number and 10. The parentheses say I have to sum the number and 10 first and then double it. And that makes sense in the context of this problem. All right, D. Suppose the length of a rectangle is 3 times the width. Okay, hold on. I got to draw this. So the length of a rectangle is 3 times the width. So if the width is W, then this length here would be, the long side would be like 3 W's, right? Oh, it says if we let X represent, so let's go back and let's let X represent the width of the rectangle. What expression do we use to represent the length? So then 3x would be the length, right? Because it says the length is 3 times the width. So if the width is x, the length is 3 times x. So 3x. So hopefully that was clear, answered some of your questions, maybe prompted some others. Get in touch with me if you have questions, and happy to answer them. And I'll see you in Chapter 4.